Hi, this is part 2 of C# value types. So far, we talked about enums, which are value types, and now I want to talk a bit about structs. Structs are value types that are typically used to encapsulate small groups of related variables. They're well suited for representing lightweight objects like point, circle, etc. Structs have a similar syntax as classes, but they are value types, and they're declared with the keyword struct. Because they're value types, they can be more efficient in certain situations. Most built-in types are structs, with properties and methods that can be called both on variables and literals. So here is an example of integer. Int is a struct, and here we're calling a property on the type directly because max value happens to be a static property. The max value of integer gives me the largest integer value, which happens to be slightly larger than 2 billion. Now here we are calling toString, the method, on a variable number 1. Number 1 is the variable that includes the largest integer, and now we're turning this to a string, and it gives us a string that includes all those numbers. I could also call this method directly on a literal. Here I have 11, which is an integer literal. I'm calling toString directly on my literal, and again it's going to create a string that includes the numbers, in this case 1, 1. Now there are many more methods besides toString, for example tryparse. Tryparse tries to parse a given string, in my case 11, which is this string right here, and we try to parse that 11 to a variable of type double. This is possible, so tryparse is going to return the value true, because 11 can be parsed to a double, and the result is 11.0. Now, if I would have passed a different string, let's say hello world, then tryparse would have returned false, because hello world cannot be converted to a double. Here is an example of a struct that has been declared. This is a point representing a point on the Cartesian coordinate system. We have an x and a y. Notice we have a getter only. So this is an immutable type. We don't allow to have the point changed once it has been created. We have a constructor. The constructor initializes both the x and the y. Now, I also have a toString method that I'm overriding, and the toString method prints the parentheses and then comma separated the x and then the y. Just as a heads up, I want to point out that there is a new simplified syntax to create strings. It looks like this. We talk about string interpolation, and we use the $sign in front of the double quote to indicate that we use the string interpolation syntax. Now let's have a look at using structs. So here I use the constructor to create a point, 2, 3. I assign it to a variable p1 of type point, and I print it using the familiar syntax string format. Not surprisingly, it shows me that my point p1 has the coordinates 2, 3. What might be more surprising is the following. I can also create a point p2 using the default constructor. This would be impossible in the context of a class, because in a class I lose my default constructor the moment I create my own constructor. So that is different in structs, where I always have a parameterless default constructor. And when I look at my p2, I can see it has been initialized with the default values 0. Let's have a closer look at the differences between classes and structs. First and foremost, classes are reference types and structs are value types. Their implications. One of them we mentioned already. It is the performance advantage that you might gain from using structs in certain situations. It also affects the default value. For classes, the default value is null. For structs, the default value is the default initialized struct. In our case, that would have been the point 0, 0. In classes, a default constructor is provided if and only if no constructor is declared. In structs, a default constructor is always generated. In classes, you can declare your own default constructor. This is not possible in structs. Writing a parameterless default constructor in a struct would lead to an error. If you write a constructor in a class, there's no need to initialize every single field. The fields that have not been initialized explicitly will be automatically default initialized. Again, this is different in structs. Whenever you write a constructor in a struct, every single field has to be initialized explicitly. Classes can inherit from other classes. We don't have inheritance between structs. Structs cannot inherit from other structs. They cannot inherit from other classes either, except of course system object. This is the root of all types in C#. Because structs are value types, they behave differently than classes. This has a special implication when we try to change them from within a method. This can lead to subtle errors. It can easily happen when you refactor and when you shift functionality between methods. Here I have a guideline. Unless you have a really good reason to do otherwise, make your structs immutable.